Okay, so now we're going to do part 2 of lesson 1.3, and this is equations with infinitely many solutions. And again, sometimes instead of infinitely many solutions, you might see the term all real numbers. So in order to have a solution that has infinitely many solutions, you have to obtain an equivalent equation that is true for all real number values of the variable. So, let's see, all real numbers number values are true for the variables. Okay, so this would be such as if after you finish simplifying, if you got 5 equals 5, that is always going to be true. So if you had ended up with something like that, then you know that's going to be infinitely many solutions or all real numbers. So let's look at an example of what that means. So here's example 2, and we have 6x plus 4 equals 4 times 3 halves x plus 1. Okay, so if we're looking at this problem, first of all, this one's already done, so we're going to do distributive property here. And let's think about that, what that does. If we do 4 over 1 times 3 halves, what we would do is simplify. So that's a 1 and that's a 2. So that gives us 2 times 3 is 6. Okay, so here we get 6x, and then 4 times 1 is 4. Bring this down, 6x plus 4 equals 6x plus 4. So really, you should even be able to stop here. When you see they're the exact same equations, it's going to always be true. So no matter what I put in for x here, whether it's 5 or 100, I'm going to put the same thing here. So those are going to always equal each other. So no matter what I put in for the x, any real number, it's going to make that true. However, if you continued and you didn't see that right away, if we were to go ahead and move the 6x's, you would see that those would cancel out, leaving you with 4 equals 4, which is always true. And so that means infinitely many solutions. So again, what did you notice? So on infinitely many, it becomes the same equation. No solution, what did we notice? We noticed that the coefficient in front of the x value or whatever variable you have is the same, but our constant term that's with them are different. So that can never actually happen. So that's the difference between a no solution, and on this one, it would be infinitely many solutions. Oops, there you go. All right, so let's go ahead and try a few of these on our own. So what I would like you to do is I would like you to pause and try these in your notebook. And once you have them all done, then you can continue and check. Okay, for number 1, you should have quickly realized that you had the same value of the coefficient, the 2x. That's the same value no matter what you put in for x. But you can't add 1 and subtract 1. They're never going to be equal, so that's going to be a no solution. And this one, after you do distributive property, you get 3t minus 2. On this side, you have the exact same thing, so that's going to be infinitely many solutions are all real numbers. And then for 3 and 4, again, once you do your distributive property, you get the same thing here, so infinitely many solutions are all real numbers. And for number 4, once you do distributive property, you get the same coefficient with the same variable. So if that's true, this is going to be the same value, but you can't subtract 4 on this side and add 30 to this side and have something that's going to be true. So this would be a no solution.